Okay, today we are going to learn CMOS inverter.
Right click, we have to click right click, open in terminal, a terminal window appears, and here we need to type our CSH command, press enter, then if it doesn't,
Enter.
then source home install CSH. This welcomes us to Cadence tool suite, and there we have to give virtuoso space ampersand, then enter. This will load the Cadence virtuoso tool suite. Now in the virtuoso window, go to file, new, under new, library,
Yeah.
give a name to the library. Let us say experiment exp1. If that name is
Already taken. Give
we suggest give a different name. Make sure you check the third attached to an existing technology library.
Okay.
Once done,
click on apply.
Click on apply.
Next window appears. Next GPDK 180.
In this GPDK 180 has to be clicked.
Apply.
Okay. Apply.
Click.
Click OK. And once
it loads.
Once done, we can just click OK here.
Yeah, and next.
Files, go to new, cell view. In what library name we have saved? The same
Expery1.
Yeah.
We have to type in inverter because we are doing that.
Yeah.
We'll just give inverter 2.
Since you can give any cell name, click OK. Then the schematic editor window appears.
Now here in this window we need to place our
components. In order to place component, press I on your keyboard.
A window appears. We can click browse. And here
select GPDK 180. Yeah, in this
to place a PMOS first.
Since it is inverter, you are placing PMOS.
Once you highlight it, clicking
close
it. You can again set the
okay.
Now here we have parameters for the PMOS. We need to keep the length as 180 nanometer. Total width has to be changed. So just remove the total width and change it to 850 N. And just hover the cursor outside and just click, and the finger width also will get appended to the same value.
Yeah.
Once that is done, you let the fingers be 1. Then click on hide.
Yeah.
You will get the PMOS.
Place the component.
Place it. You can just click to place it. You can place one more if you want, but we don't need that. So escape button.
Yeah.
Now this I have placed the PMOS. Similarly, an NMOS has to be placed. So press I on the keyboard again.
Okay.
Navigate to NMOS. We are in GPDK 180, so navigate to NMOS.
Yeah.
Again in NMOS, we need to give the parameters.
This is the first case.
So here there are many cases in this experiment. Therefore, we need to keep the width of the NMOS transistor same as the PMOS transistor. So total width will be
850 N.
850 N.
Yeah. Now click on hide.
Now again hide. Now
place the component.
NMOS. We just place it and escape button.
Okay.
Now we will need pins. So to pick pins, we need to press P on the keyboard.
Yeah.
So we got our create pin tab. Now we need to create pins. We need to name them. So we will have VDD,
yeah,
V in,
yeah,
and G and D as ground pin. All of them will be as
input. Okay. Then click on hide.
And that we can click hide. Our pins will appear. VDD.
Place the VDD at the top.
So we can rotate it with by pressing R on the keyboard. We place that. Then we get V in. We can again rotate it and place it here. And ground, we can rotate it again and place it down. This will place all the pins.
And next we want one more pin, output pin.
Output pin. So again press P. We can type V out and change the direction to
output.
and hide it. We'll get the output pin, place it there. Thus we get all the pins. Now to make the connections, we will need to change the cursor to wire mode. So press W on the keyboard.
Do the necessary connections as per the diagram. Okay.
Now the connections all has been made for the inverter. Once we are done, we need to click check and save. If there is no errors, well and good. If there is an error in the Virtuoso window, we'll get our errors. Now since we have no errors, we'll go to create in the top and in the create we need to navigate to cell view. In the cell view, we need to go from cell view. We will have our credentials there. Now we'll click OK. Now symbol generation option appears. Now we need to
Arrange as per the diagram.
As per the diagram, the pins like
Huh.
once the pins are arranged as left pins V in, right pins V out. Similarly, we need to click apply. Now this window appears.
Block diagram will appear.
Now after the block diagram appears, you can just click check and save. Now
To Virtuoso window.
okay, அது ஓப்பனாக இருக்கட்டும். மினிமம் வர்ச்சுஸ் அப்படின்னு போகிறேன்.
Huh.
Navigate to Virtuoso window. Go to tools. Library manager. In the library manager, click on the
Library which we have created, and then make sure the inverter 2 is selected
then the
and symbol is highlighted.
Commentating kuda unnadu.
Go to file, click on new, go to cell view,
a new file appears.
a new file appears at the bottom. In this, make sure that you press _TB. This is for test bench.
Okay. Instance. Browse. We should add our inverter 2 instance here. So once selected, press close, hide this, add it,
Place it
then press
and then
escape.
press escape.
Once this is placed,
Oh,
press I.
yeah, we have start mode.
Press I.
Yeah, now press I,
Browse.
analog lib,
In that, search for VDC.
type VDC,
First one. Click on the tab to get the parameters.
and set the DC voltage to be as 1.8, and then click on hide and place the VDD as per the requirement. Rotate it.
with press R to rotate it.
Positive terminal should be connected to VDD.
Escape.
Next, similarly, V pulse. VPULSE.
Yeah,
V pulse. Let the voltage 1 be 0.
voltage 1,
Not the DC
voltage 1.
Voltage 1 be 0.
Yeah, it is in 0.
Next, voltage 2 should be 1.8.
Okay.
Period. Voltage 2 1.8. Period should be 20 nanoseconds. Period should be 20 nanoseconds, 20 n. Then next, delay rise time 1 nanosecond. Fall time 1 nanosecond. Next, pulse width 10 nanosecond.
Which is half of time period.
Next, click on hide.
Place it. Press R to rotate. Place it.
Positive should be connected to V.
Next, escape. Now we'll add pins. Press P. Type. Escape. Oh, this is
No. This is an instance.
We need to connect ground.
pin. G
Okay.
and D.
then press I and get the ground pin. Okay, yeah, click on hide. One.
Escape.
No, we require more than
We need to connect V out.
2 ground pins. Once again press I and get the components. Yeah, let it be in ground, hide it. Yeah, one more. Place there, one more.
Escape. Now we need output pin, so press P.
Create V out.
V out.
Make sure that V out.
Name is same as the diagram.
Yeah, click on hide. Place it. Escape. Okay.
Now we need to make the connections.
Connections.
So in wire mode, pressing W.
Click on check and save.
Go
Now
to launch.
go to launch.
ADEL.
ADAL.
Choose analysis.
Yeah, in trans mode, select the stop.
100 nanoseconds.
100 nanoseconds. Type.
100 N.
Yeah,
Moderate.
moderate, and click on
Click OK.
apply.
OK.
Okay, and then
Again
it
go to
appears.
Choose analysis. Check DC. Check DC. Then save DC operating point. It should be checked.
Yeah,
Next go to component
parameter.
Here we need to select component. Click.
Start.
Now in the DC checked, save DC operating point checked, component parameter checked, and select component. Select the VDC.
Are you sure it is VDC? No, it is
it
V.
is
Yeah,
V
you are
inputs.
correct. Yeah, select it.
In the pop-up window, select VDC.
Okay, click on OK.
In the task in the task bar again, bottom choose analysis.
Yeah,
Here we need to select the start and stop. Start shall be 0. Stop shall be 1.8. Click OK. Now again go to the ADL window. Go to outputs. Go to outputs in the tab. Now to be plotted, select on design. Select the input and the output wire. One selected.
While we clicking, it should appear as dotted lines.
Now go to ADL window. Click run. The run process happens. Here you need to unstrip. So click on unstrip. Select transient response. Select transient response, and again click on unstrip. Change to solid. The style to solid so that we can view it clearly. Here we observe we observe clearly that as an inverter, whenever the net input is high, the output is low, and when the net input is low, the output is high. Thus this is a
Transient response.
transient response of the inverter. Now go to calculator. In the calculator waveform,
You should click on clear buffer and stacks. Clear all stacks and buffer. Click on go to a file. Click on reset GUI. Then click on delay. Here we are copying and pasting net 7 and V out. Click on right click on net 7. Control C.
ಫಾಲಿಂಗ್ ಪೀರಿಯಾಡಿಸಿಟಿ ಅದೆಲ್ಲ ಹಂಗೇನಾ?
ಹಾಂ ಎಲ್ಲ ಕರೆಕ್ಟಾಗಿದೆ. ನೆಕ್ಸ್ಟು ಕೆಳಗಡೆ ಅಪ್ಲೈ,
Click on this.
ಕ್ಲಿಕ್. ಯಾ
This is TPLH.
similarly change the rising and falling, you will get
TPHL.
TPHL, and then for different cases
Like
similar,
we should reset GUI.
once again do that.
Delay.
Now come to the original window. Since we have to do for multiple places, click on the component. Yeah, now press Q. Yeah, there we have to change the total width as per the requirement, and similarly follow the steps wherever it is required. That's it.